So this is the second lowest graded problem on the exam, and in the version A of this exam, it was number 11. So here, remember we discussed when we disconnect things from the battery or we keep things connected to the battery, what is changing, okay? When we disconnect the capacitor from the battery, it cannot accumulate any more charge or cannot lose charge on the capacitor plate, right? So whatever you do with this capacitor, the charge, because the battery is the source of the charge, this charge, and it is disconnected, the charge is not going to change, right? Again, so the capacitor is fully charged and then it is disconnected from the battery. It means that the charge on the plates of this capacitor is gonna stay fixed. Okay, but the potential, well, the potential might change. So let's discuss that. Okay, so Q is fixed. Well, so Q is fixed. We had the initial, and Q in the capacitor is given by the capacitance times the potential difference. Okay, we have the initial values for the capacitance and the potential difference. The potential difference initially was V0, and the capacitance we can compute in a second. Okay, so what happens next? From here we can find what is the potential difference, right, initially. So it is given by this equation. So why I do this, you will see in a second. So now the potential difference finite, again, I can use the same equation, the same line of arguments to get this expression over here. So in principle now I have to compare them too. Okay, I have to compare delta V final and delta V initial. Okay, so but now I need to also find the capacitance. So the capacitance initially was given by this combination. So we had some distance between the capacitance plates. These capacitance plates have some cross-sectional, have some area A, and epsilon 0 here is just a prefactor. Okay, so the final capacitance changed. So how did it change? It changed because we increased the distance between the plates by the factor of 2. Okay, so, and this is what I indicated over here. So the distance was increased by the factor of 2. So the new distance will be 2d of the original, 2d, right? So, and therefore, the final capacitance will be 1/2 of the initial, right? So compare this equation to this and you will see that this is 1/2 of the initial. Very good. So now, let's use this fact. So let's substitute this final capacitance as it is expressed through the initial into this equation over here. Okay, so, well, we substitute C final there, we'll get this ratio. This ratio can be simplified, right? So this will be just flipped, okay, and I will have this ratio over here, it's Q over Ci, but now let's look where we started. Over here, it is essentially delta, it is the same as delta V initial, and therefore I will get that delta V final is given by 2 delta V initial, and actually delta V initial was given, it was said that it is just V0. So the final answer will be 2V0. Again, so the key point here, and we stressed it multiple times during the class, is to remember that when the capacitor is disconnected from the battery, the charge on the capacitor plate is not going to change. It's not going to change. Okay. So these facts, something like this, okay, during the stress of the exam is easy to forget. It is important to write them down, right? I mean, they make sense, but it's also important to write them down somewhere in your equation sheet, right? All right.